let's do some general transformation problems. Now, suppose I give you a graph, and I tell you that the point -2, 1, so it's that point right there, is moved to the point 1, 4. 1, 4. All right? Write a function that moves this point to its new location. Now, there's a lot of ways this can happen. I'm going to give you the simplest. I'm not going to worry about stretches in the x direction or in the y direction. Let me just write this. G of x is f x minus h plus k. I'm just going to move it by straightforward translations. We're going to use this notation a lot. Now, let's look at this. When I go from -2 to 1, and then I transform it to 1, 4, what do I do in the x direction? In x, I move what? 1, 2, 3 units to the right. All right. And then I move 1, 2, 3 units up. So g of x is going to be whatever my function f is, x, and it's going to be minus, since it's right, it's going to be -3. And then because it's up, it's going to be +3. Now these problems are a lot of fun. What they assume is that I have a function f of x, and on f of x is this point s. What happens to this point right here under the following transformation? Well, the easiest way to do this one, in my opinion, is to start with the x value. What happens to x under this transformation? X minus 3 is a shift right of 3 units. So if I take the point 4, 2, where this is my x value and this is my y value, what happens to 4? 4 under g becomes a shift to the right 3. So we're going to add 3. So my new x value is going to be 7. Next, I want to evaluate g at 7. Let's see what happens there. This is going to be 8. Now, everywhere I have an x, I'm going to put in 7. So this is f, evaluated at 7 minus 3 plus 5. All I've done is substitute in 7. Everywhere up here I have an x. So this is 8 f of 4 plus 5. This should always happen if you've done this correctly. This right here is f evaluated at 4. Well, when I look at this notation, I can write this as x, f of x, or this point right here I can write as 4, f evaluated at 4. So f of 4 is 2. It's my y value. This is always going to be your y value. So this is 8 times 2 plus 5, which is 16 plus 5, which is 21. So the point 4, 2 under the transformation of g of x gives you 7, 21. Let's do another one of those. So on f, I have f. I have the point s. And I'm going to go ahead and rewrite it this time as 2 f of 2. So f of 2 in this case is 2. Now I'm going to come down and look at my transformation. My transformation, x plus 1, is a shift left 1. So 2, my x value, 2 becomes 2 minus 1, because left we're going to subtract 1, or 1. So my new x value is 1. So what is g of 1? All right, I take my x value and I substitute it into this transformation. This is 3f evaluated at 1 plus 1 minus 2. So let's simplify. Now f of 2 is, in this case, 2. 3 times 2 is 6. So the point S, which is 2, 2, under the transformation of g, becomes 1, 4. Now suppose I have this graph, f, and I want to manipulate it. Say I want to do this reflection here. What I'm going to recommend you do to start with is make a chart of the key points. All right, so in this case, what are my key points? Well, my endpoints, of course. So the first one is -1, -1. The second one is the origin. Now I'm going to put a little star here to remind myself that that is an open circle. That's the first branch. The second branch, x is 0, y is 1, and this one is 1, 2. And I put a little circle there because that's open. I could have put a star. Now, under the transformation, g of x is equal to minus f of x, what does it do? Well, let's make another column. So if we've got minus f of x, now this is really f of x. Y and f of x are the same thing. What are we going to do to this? We're going to multiply whatever this is by -1. So the -1 becomes +1, 0 stays 0, 1 becomes -1, and 2 becomes -2. Let's see what happens to these points. This is going to be my x value, and here's my y. So this becomes -1, 1. This one goes to the origin, but it's going to stay open. And that was a straight line, so it's going to stay a straight line. The next point is going to go from 0, -1, and it is solid because it's closed. X from 1 to -2. And this is going to have the same shape or curve. Now these aren't the same scale, or you would see that there is no shrinking or stretching, and that's not a really good line. Now what if I wanted to do this point here? G of x is f of x minus 1 plus 2. Let's do the same points. All right. So let's do the same points, -1, -1, 0, 0, and I'm going to put a big line here, 0, 1, 1, 2. Now, what happened to the x? Here, this is going to be a shift to the right 1. So every one of my x's is going to move to the right 1. So -1, so this is my g. It's -1 is going to move to 0. 0 is going to move to the right 1 or 1. 0 is going to move to the right 1 or 1. And 1 is going to move to the right 1 or 2. Now over here, let's see what's going to happen to the x. At this point, what are we going to do? We're going to add 2 to whatever this functional value was. So this is g, what is going to happen to my y values here? I'm going to add 2. Where here I added 1. So this value becomes -2 plus -1. 2 plus -1 is 1. 0 plus 2 is 2. 1 plus 2 is 3, and 2 plus 2 is 4. Now, where were my open and closed points? This one right here is open, and then the last one is open. I'm just going to do that to remind myself. Now, the points we're going to graph are, this is going to be my new x, and this is going to be my new y. So I'm going to graph 0, 1. All right, and that's going to be closed. 0, 1. I'm going to graph 1, 2. And that's going to be a straight line there. Oh, that should be open, shouldn't it? Oh, I don't want to erase all that because that was quite a bit of work. Erase it that way. So I'm going to graph 0, 1. And that's solid. 1, 2 is open, and that's a straight line. And then I'm going to graph 1, 3, and that's going to be closed. And then 2, 4. And that should be open, so that should have the same shape.